Hi, welcome to Calculus 3 class. And today we're going to start our first chapter of Calculus 3. In this chapter, we're going to talk about the vectors and the geometry of spaces here. As we know, the Calculus 3 basic is extensions from the Calculus 1 and the Calculus 2. So we start out Calculus 1 and Calculus 2 for the univariate. And now the Calculus 3, we're going to expand that to multivariate. So to start this chapter, the first things we're going to take a look at the three-dimensional coordinate system. That will be our lecture number 1 here. Okay, so when we were in the calculus 1 and the calculus 2, so we talk about the one variables, right? So we have we call this coordinate planes here. So we have like x and y's here, right? So that's what is the R2. So this is what we call this the R2 space. So for example, if we give x, you get y's here. So if you have like a coordinates pair, so for example, 3, 4 here. So basically you have 3 and you have a 4 here, right? So that's what we did all in the R2 space. So today, in this chapter, we're going to expand that to the three-dimensional. So it's in the R3. That means we add one more coordinates here, right? So that means in here we have x-axis, y-axis, and the z-axis here, okay? So for any given point, like for the A, B, C, for any given point, it's just like we did in the R2. So the first value, this is the x value, and this is the y value, and this is the z values here. Okay, so for the x values here, that means you go the x, so that's why this is x, and then the b is y, then the height here is the z's here. So that is how do you, the plotting the point in the R3 is just like how do we plot the point in the R2, right? So when you have like 3 and 4, then here this is the 3 and this is the 4, and then that is the point. This is the 3, 4 here. Okay, so let's take a look at how do we kind of get familiar with these ones here. So let's take a look at our first practice examples here. So let's say I'm going to, let me change it to different colors here. I'm going to plot these 3 points. A is 0, 5, 0 here, right? So the 0, 5, 0s here. Okay, so let's see here. That means this is x is equal to 0s, right? So this, the first coordinates is always x. Then y equal to 5. So it's 1, 2, 3, 4, 5. So here, correct? Then the z is equal to 0. So I know here, this is my point A here, correct? Okay, now let's take a look at the point B. I'm going to use a different color. B is x equal to 5. So the way we do it is, so you find the 5, 1, 2, 3, 4, 5 here. Then you kind of do a parallel line to y. Then the y is 4 here. So it's 1, 2, 3, 4 here, right? Then you do a parallel line to the x-axis. And then the z is 6 here, right? So you say 6 is, so you go up here, 1, 2, 3, 4, 5, 6 is here. So you go up 6 units here, right? So that's what we did here. So in here, right? So in here you have the, so this point here is, we call this the B points, right? So A is 5, Y is 4, and then the B is 1, 2, 3, 4, 5, 6 here. All right. Okay, now let's take a look at the last, another point, C is here. C is 1. All right, so your 1 is here, X is 1. So you still do a parallel line here. Then the y is -1. -1 is here, right? So we do a parallel line here. Parallel line to x here. Then the z is 3. So it's 1, 2, 3. So it's here. Right? So 1, 2, 3 here. Right? So this is 3. So this is what? This is my point C here. Right? So it's pretty straightforward. So just drawing, sometimes some people have the trouble to draw the 3 dimensions. Okay, so now let's take a look at the next ones here. Okay, so now these ones here say, hey, you know, I give you the points here. Let's see what is the A here, right? So the point A is here. Let's take a look at this graph here. So A, okay, you start with the x-axis is what? Is what here? Let's say it's 1, 2, 3, 4 here, right? So it's here. Then they do a parallel line to y. So the A points here, the x coordinates is 4. Then y is what? Y is 1, right? So because here's 1, so let's do a parallel lines here. Then in here, then this is how many z? 1, 2, 3, 4, right? So this is 4. So this is 4. So the point A is 4, 1, 4. Now let's take a look at point B here. So the point B is here. Let's find the x first. The x is here, right? So it's what? X here is 1. Okay, then you parallel to y. Y is here. So let's see. 1, 2, 3, 4, 5. So it's 5. Then the z is going down. So here's 1, 2 here, right? So what is z here? It's -2. Okay, so these two problems basically just want to be able to read, you know, if I give you a point, how do you plot it in the R3? Or if I give you R3 points, how do you read out what is the coordinates, right? It's pretty straightforward. So the first lecture just basically let you get familiar with the R3. Okay, so now let's try to do another practice here. So for these ones here, I said, okay, I'm giving this is the box here, right? So let's see what is the remaining coordinates here. Okay, so this is 3, 0, 0. So what is this coordinates here? This coordinates, x is 3, right? So this is what? This is 3. What is y? 1, 2, 3, 4, 5. Y is 5. Then because it's on the xy plane, so what is z? Z is equal to 0. Correct? Okay, now let's take a look at this point. This point is easy because this is on the y-axis. So this point will be 0, what? 5 zeros, right? Okay, this point is easy. This point is on the z-axis. So what is this point here is 1, 2, 3, 4, right? So it will be 0, 0, 4 here. Okay, so now let's take a look at this point here. This point is on the xz plane and it's not on the y, so I know y has to be equal to 0. So in here the x is 3 and the 0, 1, 2, 3, 4. So it's 4. So it's 3, 0, 4. Correct? Okay, of course, this point is easy. This is origin. So what is here? 0, 0, 0. Okay, now let's take a look at this point, right? This point, so this point here, the x is equal to what? X equal to 3, and the y, so this point here is x equal to 3, y equal to 5. Then in here, I'm going up. What is up things here? The up is what? It's the same planes here, right? So it's 3, 5, 4 here. Okay, do you get that? Okay, so we have like 3 problems. Just let's try to get familiar with the R3 planes here. Okay, so the next thing here is also pretty easy here. So we just introduce some basic formula we're going to use later. So this is the distance, you know, the between the 2 points. Like we always said, you know, let's take a look in the R2s here, right? If you still remember, let's review. In R2, that means if I only have x and y. So in the calculus 3, you will hear a lot of the time when I introduce a new topic, I will say, hey, let's go back to review what we did in the R2. Then we just expanded that to the R3. So R2 will tell you if you have 2 points, right? X, Y, 1, 1, and the X2, Y2 is here, right? So the distance between these 2 points, we all learn that in our algebra or in our geometry. So here, this will be what? Will be x2 minus x1 to the square plus y2 minus y1 to the square, right? So that's what we learned before. So now in here, you know, in the R3 is here, right? So basically what? Basically, we just have the one actual coordinate. So what is the coordinate? So here we have is a z coordinate. So we follow the same in R2, and then we just add the last coordinates here. So it's z2 minus z1 and square, right? So you add them together, right? So it's pretty simple. Okay, so now let's try to take a look for these ones here. Let's see what is our answers here. So they want to find the distance between these 2 points. So it's pretty straightforward, right? So the distance will be what? Okay, so the square roots of the first one, so it's 7 minus 4 to the square plus what? 5 minus 6 to the square plus negative 2 minus 1 to the squares, right? Okay, so here it will be square roots 9 plus 1 plus what? Plus 9, right? Okay, so what is the distance here? Will be square roots of the 19th here. So this is a pretty, you know, the easiest here, right? Okay, so now let's go to the next ones here. The next ones here, we just want to introduce some the terminologies here. So this terminology is what is the coordinate planes here, right? So in the R2s here, right? So in R2, okay, so in R2s here, right? So we say the coordinate plane is x and what? Is x and y here, right? So now in the R3s here, we have 3 axes here. Okay, so this is x, y, and z's here, right? So, okay, so when we talk about the YZ planes here, YZ plane, that means, you know, it's this planes here. So this is, we call this YZ planes here. It's just made of the y-axis and the z-axis here, right? So then the xz planes here, right? So the xz plane will just be what? Will be the plane made of what? X and z, right? So will be made of the x and so like in here, going to expand that also, right? So will be the x and z, and then the same things here for xy plane is just like xy here. Right, so like here you can kind of the, you know, like just what we learned in the, you kind of expanded it. So the XY plane will just be the plane, you know, formed by X and the Y axis. XZ plane will be the plane formed by X axis and Z axis here, okay? So now in here we have one, you know, typical the problem we have is very difficult to, you know, to graph. So in here they tell you if a variable is missing from the equation, then the graph will be parallel to the axis of the missing variable. So this is a pretty good kind of the hint to try to help us to graph, right? So take a look here. So if I have my first graph here, right? So this is x equal to a. X equal to a, right, is a graph, right? So it's a plane. Because y is missing and z is missing. So that's why this plane, right? This x equal to a, the plane, is you know, going to intersect at the x-axis, but going to parallel to y-axis and z-axis. So the same way, if you have y equal to b, so y equal to b, the x is missing and z is missing. So that's why this is the planes, right? So this is the plane going to what? It's going to parallel to the x-axis and the z-axis. So basically, this plane is kind of the perpendicular cutting through the xy planes here, goes through the y-axis, right? Then it's parallel to x and z. So the same way for this ones here. So this is the one, z, right? So the missing x and y. So that's why this plane is cutting through the z-axis and parallel to the xy planes here. As in here, you can see this plane is parallel to the xy planes here. Okay, so now this one is a little bit special, right? So this plane is kind of like, they lean over the two axes here. So these planes here intersect z at 3 and x at what? X2s, right? So if you find like the line here, because this plane goes through the 3 and the 2. So if you find the linear equation here, this will be 3x plus 2z equal to 6, correct? So it's 3x plus 2z equal to 6 because it is missing which variable? Y variables here, right? So this plane is kind of like like a touch the z-axis and the x-axis, and the parallel to which axis here? Parallel to y-axis here, right? So can you visualize that? It's kind of like a three-dimensional. So if you put it like a plane, like a lean over the two axes here, the x-axis and the z-axis. So that plane going to be parallel to what? Parallel to y, right? Okay, so now let's take a look at this ones here. So these ones here, they say, hey, let's try to describe these planes here. Let's see if we can do it, all right? So this is the one, this is the plane, right? It's parallel to what? X-axis and the z-axis, right? Can you visualize that? And this plane here is going to perpendicular cutting through the xy plane and goes through the y-axis. So what is the answers here? So what is the answer for this ones here? This one will be what? Y equal to what? Y equal to 4. So this is the plane, is y equal to 4, right? So it's all the points at this planes here. Okay, so this is the one. Okay, so let's take a look at B's here, right? So this is the one, is the plane, kind of the lean over the z-axis and the y-axis. So what is this plane? Let's take a look. So because this is the kind of the line, you lean over. So if I can find a linear equation for this ones here, so this one, z is 4, y equal to 2, right? So the linear equations I can find will be what? Will be 2z plus 4y equal to 8, right? Or if you simplify that, you can say z plus 2y equal to 4, right? So this will be the, if you find the linear equation for this one, this is z plus 2y equal to 4, right? So if you set z equal to 0, y equal to 2, y equal to 0, z equal to 4. So this is the one determinant of planes here, right? So this is the plane here, right? So this planes here, right? So this plane, that's the plane is z plus 2y equal to 4 here. Okay. All right, let's take a look at the next ones here, right? So the next ones here, this is also is a review. We extended what we learned before. So let's take a look here. So like I say, let's review what we learned in the R2s, right? So in the R2s here, do you remember what is the formula for a circle? At the center, x1, y1, and the radius equal to r. So we know how to find the circle, right? So we say this is x minus x1 to the square plus y minus y1 to the square, and equal to what? Is equal to r squared, right? So we extend it to the r3. So instead of calling the circle, what do we call here? Sphere, right? So the sphere is kind of like the basketball. So they have center ABC. So it's similar to circle, will just be x minus a squared plus y minus b squared plus z minus c squared. What is my radius? Is r, right? So it's r squares here. So it's just a simple formula expanded from the circle to a sphere. Okay, so let's take a look at this one here. So the first one is pretty easy. Let's say, hey, write the equations of a sphere of the center is equal to 2, 3, negative 4, and the radius is 5. So this one is easy. So we say, okay, so this is x minus 2 to the what? Square plus y minus 3 to the square plus what is here is z minus 4 or z plus 4. So it should be what? Z plus 4 to the squares, right? Because we set each one equal to 0, solve for that. So this will be z plus 4. So what is equal to here? Equal to r squared. So it's 25. So this is the formula, not the formula. This is what is this spheres here. Okay. All right, so now let's take a look here. The next one's here, right? So let's say, hey, find the center in the radius of the spheres here. Okay, so this one's here. So you see here, I have x here, okay? And I have y here, and I have a z here. Okay, so the z is good, and then the x and the y, we have a, we need to complete the square in order to be able to write like x minus, we want x minus a squares, right? And we want y minus b squares, right? So I need to complete the squares here. So this one's here, this is x square minus 6x. You guys still remember how to complete the square? So what did you need to do here? You need to divide this number to what? To half, right? So when you divide it to half, what is that? It's 3. Then you add 9, right? So it's 3 to the square. Okay, so then plus, then y here, so it's y squared plus 4y, right? Then what you need to do here, you need to break this one to a half. So if you break this one to a half, it's what? It's 2, right? So then you 2 to the square is 4. Then the z is already in a perfect square, so it's z squared is equal to 1. But be careful here, right? Because I add 9, I add 4, right? So can I just add 9, add 4? No, I need to do what? I need to add back. So if you add on the left-hand side, then I need to add on the right-hand side. Okay, so now this is good, right? So here, this is a complete square for x. This is a complete square for y, right? Okay, so now you can write this is x minus 3 to the square plus, what is here? Will be what? This is y what? This is y plus what square? 2 to the square plus z squared and equal to what is 14 here. So if you don't remember, right, so you need to go back to review what we mean the completed square, right? Okay, because we try to match the sphere formula. So for here, okay, so for this sphere, so where is the center? ABC, so what is here? Center is what? What is the center here? Here, 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 right? So what is the center? Let's write it. So will be what? 3. So what is y plus 2 will be? Negative 2. So z squared is what? Is z minus 0, right? So it's zeros here. Then what is the radius? So 14 is equal to r squared. So what is radius? Square root of what? Square root of 14, right? It's very good. All right. Okay. So now the last problems here. Let's see here. This is the one really, all the previous one is very simple review. So the number 8 here is really try to test your understanding about the 3 dimensions, so graphing and the concept, right? Okay, so now let's take a look at this one. Here, the first one here. Let's see what type of the graph I'm giving, right? So I have x, y, and the z's here. Okay, so the graph here, this is x squared plus z squared equal to 4. Well, this one's here, if you only have x-axis and z-axis, what do you have here? That's obviously is a circles, right? It's a circle with radius is what? It's a 2. So basically, if you only look, right? So if you only look at the z-axis here, okay, so let's do like this. Okay, so if you only look here from the, from the xz axis here, right? So then you will see, that's what the hard part is. Some people, they have a hard time to visuals, right? So here, okay? So that's why if you only look at the x, the x and the z, so can you see that if you kind of focus on the x and the z, so it's a circle of the x and the z. So what is the y value? Y value can be what? Can be everything, right? So basically, this ones here, y can be anything, can go like this, can go like what? Can go like this, right? So what is this graph is? So what is this ones here? It's the cylinders, right? So it's cylinders here. So this one's here, this is a cylinder. Okay, so it's a cylinder of the, what is the radius? The radius is equal to what? Radius is equal to 2. And go along with which axis here? Is along the y-axis, right? Because it's going y. Y can be any number. Okay, so next one's here. This one is pretty easy. It's here. Okay, x squared plus y squared plus z squared less than 1. So what is this one's here? This is a sphere, right? So if you graph your, this is x, y, z here, right? So if you graph it, so here is like a, can you see that? So can you see my terrible graph here? All right, so here use a different color. So it's a sphere, right? So it's kind of like a sphere, go like this, right? So it's a sphere, and because this one's here, look here, right? So it's less than equal to 1. So that means it's a solid, right? So it's everything inside is here, right? So it's a solid sphere. So that's why we say this is a solid sphere. What is the radius? Radius is what? Its radius is 1. Where is the center? Center at 0, 0, 0 at origins, right? Okay, so now let's take a look here, right? So part C is here. Let's see what is the part C here. Okay, so this is X. So this is X, this is Y, and this is Z here. Okay, and now let's take a look. X equal to 3, right? So let's see here, X equal to 3. So 1, 2, 3. So X equal to 3, Y equal to 4. So it's 1, 2, 3, 4. Remember, that's okay, so that's our point. But remember, see here, now I don't have Z's here. So what happens here? That means Z can be any numbers, right? So my graph here will be what? My graph here will be like that. Okay, so what is the graph here, right? Because you need to passing through x equal to 3, y equal to 4, but z can be any value. So this is a line. This line have to pass through which point here? Passing through 3, 4, and 0, because z is equal to 0, right? And this line going to be parallel to what? Z-axis. You get that? Okay. So now let's take a look at the other threes here. Y plus z less than equal to 1. See here. Let's take a look at what is this one here, right? So, okay, we're missing the x. So that means whatever the graph we have has to go parallel to x-axis, right? That's what we learned from these chapters here, these sections here, X, Y, Z here. Okay, so for y plus z, right? So I'm going to bring the y and the z dots, right? So if I only look at y and z, right? So if I only look at x, so I only look at y plus z. Okay, so I only look at y plus z. So if y plus z less than equal to 1, so you can break this one into like a y plus z less than equal to 1, y minus z less than equal to 1, negative 1 plus z less than equal to 1, or next one, next z less than equal to 1, right? So if you look at the YZ axis here, so what is this one going to give you? This one going to give you 4 lines, right? And then you're going to, because it's less than equal to, so what happens here? You're going to have a solid areas, right? And now because it is, the z, the x is not showing, so I know this is going to be parallel to what? Parallel to x-axis. So basically, you will have something like this. Okay, so you will have something like this. Did you see here? Right? So you will have a solid square box, right? So this one will give you a solid square box, right? Solid square box, right? So it will be like something like in here, right? This is a solid square box. And where they parallel to here, and so this is solid square box and along with what? The x-axis. Correct? All right. Okay, so now this one, okay, let's take a look. This is x squared plus equal to 1. That means that will be x equal to 1 and x equal to negative 1, right? So we say when x equal to 1, so what is this here? So that means it's the 2 planes, right? We have 2 planes. We talk about this one. One is x equal to 1 plane and the other is x equal to negative 1 plane. And both these planes here are going to parallel to what? Both are going to be parallel to which coordinate plane? Because it's only have x, right? So we're missing y and z. We're parallel to the yz planes here. All right. Okay. So now, so these ones here. Okay, so these ones here, this is just like what we did before. So, look, here's x, here is x. So I need to combine. So y just by itself is good. Then the z here, z, so here's z, here is z, right? Okay, so now what method I need to use? Complete squares, right? Okay, so let's combine the x minus 2x, combine the x together, the green one, divided by 2, so it's 1. Then square 1, so it's 1. Okay, y square is perfect already. Then plus z square minus 6z Divided by 2 is what? It's 3, then you square is 9, right? And this 10 move to here is negative 10. So what did you add here? You add what? You add 1. What else? You add what? You add 9 here, right? So you add 1 and you add 9 here, right? So in here, let's see here. So what is in here? So that means, so in here, do you need to do what? So I need to add what? I need to add 9. I need to add 1 here. So this one here will give you x minus 1 square plus y square plus z minus what? Z minus 3 square and equal to what? And equal to 0, right? So what is this? So this is what? This is a point, right? So this is really is a dot here, right? X, Y, Z. So x equal to 1, y equal to 3, right? So it will be this dot here, right? Because y equal to 0, right? So we'll be in here, we'll be on the xz plane, and because the radius here is equal to 0 here, right? So that means it's a dot. It's not a sphere. It's just that because the radius is equal to 0, so it's a point at what is 1, 0, and 3. Okay, and that's it. And so like the first lecture is pretty simple, and basically it's a quick review, and we add a couple new things related to the R3, like a sphere and the distance formula. And the last problem, problem number A, is really pretty good problem and give you the idea how do you look the graph in the R3s here, right? And also remember the key things here for any equation. If you're missing, the variable is missing, that's the axis your graph going to be parallel to. Okay, that's it. And so it's nice to start our Calculus 3 class, and this is our lecture number 1 here. And so hope you don't have any questions. If you have any questions, feel free to send me an email, and or we can discuss, right? So, okay, that's it. And have a nice day, and looking forward to talk to you on our next lecture, lecture number 2 here. Okay, bye.